Introduction to Solutions and Aqueous Reactions, a review of how to assign oxidation numbers. In this tutorial, we will be going over a review of how to assign oxidation numbers, the rules, oxidation numbers and free elements, oxidation numbers and neutral compounds, common oxidation numbers, exceptions to the rules, steps for assigning oxidation numbers and compounds, some examples, and finally, some practice. A review of how to assign oxidation numbers. What is an oxidation number? An oxidation number is the charge of an ion or the apparent charge of an atom in a compound. They're assigned according to certain rules. The general range of oxidation numbers goes from -3 to +7, but it also includes 0. Oxidation numbers are found in the upper right-hand corner of the element box of the periodic table. Of course, depending on the periodic table that you have, if oxidation numbers are even included. So for potassium, the oxidation number is +1, and for chlorine, we have a range of oxidation numbers going from +7 to -1. The oxidation number of every atom in a free element is 0. So what do we mean by free element? A free element is an element not combined with another element in a compound. So for example, with metals, magnesium, copper, calcium, iron, all would have an oxidation number of 0 if they were represented by themselves in a chemical equation. Your nonmetal diatomics, oxygen, hydrogen, chlorine, fluorine, nitrogen, iodine, and bromine. Nonmetals by themselves, carbon, phosphorus, sulfur, selenium. Anything in a chemical reaction represented as an individual entity will have an oxidation number of 0. In an ionic compound consisting of monatomic ions, each atom has an oxidation number equal to its ionic charge. So let's look at an example. CaCl2. The only charge that calcium can be is +2. So that's going to be +2. Now, the overall charge has to be 0. So chlorine, if calcium is +2, has to be -1. And then we multiply that -1 times 2 to give us -2. So +2 minus 2, overall charge 0. Let's look at FeCl2. Now Fe has multiple oxidation states, but if we look at this chemical formula right here and we uncrisscross this, we know that this 2 is going back to the Fe. So it's going to be Fe +2. If iron is +2, chlorine has to be a negative number, so the only negative number associated with chlorine is -1. -1 times its subscripted 2 will give us -2, and the overall charge will be 0. FeCl3, iron 3 chloride. Again, we're going to take that 3 and uncrisscross it to give us Fe +3. Chlorine's going to be -1. -1 times 3 gives me -3. The overall charge is going to be 0. Group 1 elements will always have an oxidation number of +1. So sodium, lithium, potassium all have a charge of +1. Group 2 elements will always have an oxidation number of +2. Calcium, magnesium, beryllium, all +2. Fluorine always has an oxidation number of -1 in its compounds. So these are some examples of common oxidation numbers. In most compounds, hydrogen has an oxidation number of +1. But an exception to this is when hydrogen forms a compound with a metal, it has an oxidation number of -1. These compounds are known as metal hydrides. So if we have lithium hydride, lithium has to be +1, therefore hydrogen has to be -1. Calcium hydride, calcium has to be +2, so hydrogen has to be -1. -1 times 2, -2, +2, overall charge 0. Most compounds, oxygen has an oxidation number of -2, but oxygen will have a -1 oxidation number in compounds called peroxides. So in this case, we know that hydrogen is going to be +1 because oxygen is more electronegative than hydrogen will be. So it has to be +1. So +1 times 2 gives me +2. overall charge for this neutral compound has to be 0. Therefore, oxygen has to be minus 1 times 2 minus 2. So in this case, oxygen is going to be negative 1. Now, oxygen can also have a charge of negative 1/2 in superoxides, but we don't often see that. Steps for assigning oxidation numbers in compounds. Step 1. Assign oxidation numbers to atoms in the formula in accordance with the rules above. Step 2. If there remains one element for which no rule applies, give that element an oxidation number that will make the total for the compound electrically neutral, in other words, equal to 0. But understand this, the total of the oxidation numbers in a compound must equal 0. I can't stress that enough. Remember to multiply the oxidation number of each atom by its subscripted number. Don't forget to do that. Let's look at some examples. We have H2SO4. Most of the time, hydrogen is going to be plus 1. So plus 1 times its subscripted 2. So we know hydrogen is going to be plus 2. Here we know oxygen is going to be negative 2. So negative 2 times 4 gives us negative 8. So if this is plus 2, because this was plus 1, and oxygen is minus 2 times 4, and that gives us negative 8, this whole compound is electrically neutral, so it has to be 0. Sulfur, no rule directly applies. Therefore, to make this electrically neutral, it has to be plus 6. So therefore, sulfur must be plus 6 in order to make the whole compound equal to 0. Let's look at another example. Potassium can only have a charge of plus 1. Plus 1 times 2 gives me plus 2. Now let's go to oxygen. Oxygen is going to be negative 2 times 7 gives me negative 14. Negative 2 times 7, negative 14. K plus 1 plus 2. Whole thing has to equal 0. With chromium, no rule directly applies. So if we look at this, we know this has to equal plus 12. So we're going to put in plus 6 times 2. That'll give us plus 12. The whole compound's electrically neutral. So due to the fact that chromium does not have a rule directly assigning it an oxidation number, a number is assigned to it to make the formula electrically neutral. The only concern is that we have to take into account that chromium has a subscript of 2. So you can't just say, oh, it's plus 12. That'd be ridiculous. But we can say plus 6 times 2 gives us plus 12. Now let's go through and do some practice. Let's look at an example. Carbon and H2CO3. We'll start out with the elements that we absolutely know the oxidation numbers to. So most of the time, unless it's with a metal, hydrogen is going to be plus 1. So plus 1 times 2 gives me plus 2. Oxygen, most of the time, it's going to be negative 2. So negative 2 times 3 gives us negative 6. Whole thing is going to equal to 0. Carbon has to be plus 4. And that's our answer for that one. Ni in NiBr3. We're going to uncrisscross this 3 because nickel can have multiple oxidation numbers. Therefore, nickel is going to be plus 3. Bromine has to be negative 1. So 1 times 3 gives us negative 3. Everything's equal to 0. Li2CrO4. Li is a group 1 metal. It has to be plus 1. Plus 1 times 2 gives me plus 2. Oxygen is going to be negative 2. Negative 2 times 4 gives me negative 8. Whole thing is going to be equal to 0. Chromium, like we saw before, has to be plus 6. Nitrogen in NO3 minus 1. Now be careful here. Nitrogen has a bunch of oxidation numbers. We'll start out with oxygen, which we know is going to be negative 2. Negative 2 times 3 gives us negative 6. Here we have a polyatomic, so it's not going to be electrically neutral. Instead, it's all going to be equal to negative 1, which means the nitrogen has to be plus 5, because plus 5 minus 6 gives us negative 1. N in NH4 plus 1 really tends to trip people up. Hydrogen can only have a negative charge if it's with a metal. Nitrogen is not a metal. Therefore, hydrogen has to be plus 1. 1 times 4 gives me plus 4. Overall charge is going to be plus 1, which means nitrogen has to be negative 3. Be careful of this one. Zn in ZnCO3. Zinc has to be plus 2. because that's the most common one associated with zinc, and I've really never seen another oxidation number with zinc other than +2. Oxygen is -2. -2 times 3 gives us -6. Whole thing is going to be equal to 0. Bring this down. Carbon has to be +4 to make this electrically neutral. Al and AlOH3. This 3 gets crisscrossed back to Al, so that's going to be +3. Whole thing is going to be equal to 0. Hydrogen has to be +1 because it's not with just another metal. So 1 times 3 gives me +3, which means this has to be -6. So -2, which makes sense for oxygen, times 3 gives me +6. So the charge in AlOH3 for aluminum is going to be +3. Cl and GaClO33. All right, well, let's start out with the Ga. We know if we uncrisscross this, gallium is going to have a charge of +3. So +3. Whole compound is going to be electrically neutral. Oxygen is going to be -2. So -2. Now watch this here. -2 times this 3, which is only affiliated with that oxygen. So -2 times 3 is -6. -3 again, -18. So when we do this, we know that chlorine ultimately has to be equal to +15. There's a subscripted number of 1 right here. So that means we're going to have an oxidation number of +5 for chlorine. So 5 times 1 times 3 gives us 15. The whole thing is electrically neutral, but you always go back to the original oxidation number. So chlorine would have an oxidation number of +5. Again, you really need to be careful and think about what you're doing and if it makes sense. So what did you learn? We went over a review of how to assign oxidation numbers. We talked about oxidation numbers in free elements, oxidation numbers in neutral compounds, common oxidation numbers exceptions to the rules, steps for assigning oxidation numbers in compounds, some examples, and finally some practice at the end. Need more help? Feel free to contact me. Have a great day.